Hey, this is Leach with Simpson Math, and in this video I'm going to be talking about how to find the one proportion z interval. I'll present you with two separate problems. We'll go through how to do it by hand, and then I'll show you how to do it on an internet applet from the Rossman Chance suite of applets. Then I'll show you how to do it on TI-84, and then lastly on Excel. I'll show you a quick way to do it on Excel, and then kind of a way to build up a kind of fancy little fancy little calculator on Excel. So let's get started with the example. All right, so we kind of run a little business where we make enamel pins. Here's two of ours. It's a pumpkin pie and an apple pie. This is a green apple pie. And we have several others, gamer and nerd related things. So this is kind of a problem that we could do if we really cared hard about being a successful business. It's really just a hobby, an excuse for us to make the pins we want. So here's a problem. It says, I'm thinking about designing a new series of enamel pins for sale. I would produce these pins if I can be convinced that at least 33% of my current customer base is interested in buying at least one of them. Well, just let me pause and just give a little bit of where that 33% comes from. When we make these pins, there's something called a minimum quantity order in MQO. And so we need to really make at least 100 when we do. And at that current rate, we can then turn around and sell these pins for $10 to $11, about $10, and it costs us about $3.33, give or take some different variables that it goes into making it. So it costs us about a third, basically like a third of a dollar to produce it compared to what we can sell it for. So that would be about breaking even if we would be that 33%. So that's kind of where that number came from. So I'd be convinced of at least 33% of my current customer base would buy at least one of them. So suppose I was to take a random sample of 50 of my current customers, and I find that 21 or 42% of them are interested in buying at least one pin in this new series. I will then make a 90% confidence interval, estimating the actual proportion of my current customer base interested in buying at least one of these pins. Then based on this confidence interval, should I produce these new pins? And then we're going to assume that my customer base is large enough that 10% condition is satisfied. Shifty eyes, it's not. But we're just going to, for the sake of the problem, going to pretend that that's the case. So one other thing I would like to point out that it was real nice in writing this problem, that I said that I gave both 21 and 42%. You're often not going to see both. So let's talk about our givens. So first up, we see that I say that 50% of my current customers is who I sampled, and so that's my sample size, that 50. This 33% of here, it is a number that is a problem that was given to me, but that's going to be more of kind of like a call to action. What am I going to do after I find my confidence interval? So this is not something I'm going to use in my confidence interval just yet. Like I said, it was kind of a nice gift that I gave both 21, my number of successes that I found, and 42%, the proportion of successes, or my sample proportion, which is p hat. So often you're not going to find both of those. If you only are given the number of x's, then you'll have to do a little bit of division. So in this case, 21 over 50 to get that 0.42. Sometimes you might not be given that 0.42, and you might, depending upon your use of technology, have to multiply those together, multiply the 50 and the 0.42 to get the 21, which is what one of our conditions is. So we do have those little conditions to check. I did say that I did a random sample of my customers. Each customer, whether they buy it or not, is independent of others, and a little bit of an eye roll that sure, the 10% condition works. It is important, of course, that we check this, that n times p, which is my number of successes. This 50 times this 0.42 gives me 21, which is no coincidence that we get that same 21 there. So that's that same x, that is x right there. So that has to be at least 10. So my number of successes have to be at least 10, and my number of failures has to be at least 10, which is safely there, which is 29. You really only have to check the smaller of the two. Remember, p and q are complements of each other. So if you're in a hurry, you could just have to check the smaller one, because then the other one should then be fine. We're then set to find a 90% confidence interval. So that's my level of confidence. So then I need to find what my z-score would be. My z-star would be my level, my confidence, my critical value. So I'm going to find my critical value. So I'm going to draw a picture just for myself. So if this is the middle 90%, we do the middle percent dance. Everything is 100, 90% in the middle, get rid of it. On this side, we have a total of 10%. And each, then it's 5, because this is perfectly symmetric. So that's how we get those 5s. Basically, it's 1 minus the 90 halved. But I don't like to think in formulas. I think in that big concept. So notice if I add up 5, 90, and 5%, I get the full 100%. So using what we know from the normal model, I just made a video about that recently. Go check it out. We can get our 1.645 and negative 1.645 are these cutoffs. You should also be able to, you should know 90, 95, and a few others. There should be numbers that should be fresh in your mind that you might not have to look up. 90 is always going to be this 1.645, 95 is always going to be 1.96, so forth. Or look it up using the table or technology. And then last time, I'm also going to need my standard error. So my standard error of p hat is the square root of p hat q hat over n. So I'm just going to plug in, and I'm going to use the decimals here since it terminated nicely. So 0.42 times 0.58, or 1 minus 0.42, and then divide that by 50. Use technology, your calculator sitting beside you, whatever, and you get about 7%, 0.0698. You might also see this instead of written as SC of p hat as like S sub p hat. That would be a similar thing. All right, so then let's make our confidence interval. So I like to, whenever I need to go back to the basics and think about confidence intervals, think about what it is that I'm making. Well, at the end of the day, the confidence interval is your point estimate plus or minus some margin of error. Your margin of error can be broken down into our critical value times the standard error. So I have this point estimate that I know is wrong, but close. And in this case, when we're doing this type of interval with with proportions, my point estimate is a p hat. And then our critical value is the z star, and we just found our standard error. So let's plug in those values that we found up here. So our p hat is this 0.42, oof. This z star is 1.645, and the standard error is the 0.0698. So then all the math I have to do here is really to just multiply these two things together, and I get 0.1148. So that's my margin of error. This is a pretty wide confidence interval, because this is about an 11.5% margin of error. So times that by 2, 23 percentage points wide. So this is kind of a pretty wide confidence interval. So to find the endpoints, the lower bound, upper bound. So this, again, remember, this is one way to write your confidence interval: point estimate plus or minus your margin of error. The other way is with your lower bound, upper bound. So literally just take your 0.42 and subtract your margin of error, and we get this about 30.5%, and then just add them together, and you get the about 53.5%. So what should I do? Me, this business owner, I'm taking a look at my market research, and I saw that somewhere between about 30% and about 54% lies the true proportion of all my customers who would buy this pen from me. Well, I said that I would only produce this if I could be convinced that over 33% of my customers would buy this pen. And notice that there's a chance that it's as low as 30%. I might be like, oh, well, it's close enough and kind of go for it. But if I was to be hardline going for, nope, I need to be convinced it's at least 33%. This is not enough, because there's evidence it could be 33% or actually lower. So I should not produce the pen. And I have this explanation here in words. As kind of a follow-up, I said, alas, that data didn't convince me to produce these pens. So now suppose I took another random sample, but this time I asked for a larger amount of them and a larger confidence interval. So I asked a larger number of my customers and a larger confidence level. So my sample I'm going to have, so one that by increasing my sample size, that should decrease the confidence interval, but I am at the same time increasing my level of confidence, so I'm making a better confidence interval, which is making it wider. So let's see how this plays out. So in the sample of 150 of my customers, 68 said that they would buy at least one of these. Notice I'm not giving you p hat in this case. So we're going to construct this on a 95% confidence interval, estimating this, and again, what should I do? So again, we're assuming 10% condition. My sample size went up, so of course NP and NQ hat are going to be fine. So 150 for my N, my number of successes was 68. So I need to find this p hat this time. So it's going to be the 68 over 150. And this is a decimal that does not terminate. It is 0.45 and the 3's go on forever. So if I was to be doing this math by hand for the standard error, I would use the fraction as much as possible without having to round, or make sure to put in enough 3's that is past however you're going to round to. If you're going to round to just 2 decimal places, which I wouldn't, I would go up to probably at least 4, you should put in at least this many 3's, but I would actually probably at least do one more than the number of decimal places to which you're going to round. All right, so then my level of confidence is 95, so that's going to adjust my Z star to be just a bit bigger. That's the dial which controls our level of confidence. We're going to go out to be 1.96. All right, so now same process as before, but I have a new p hat, a new Z star, and a new standard error. This time notice my standard error is smaller, even though my Z star is bigger, but when I end up multiplying, it shrunk down from being, it was like about 11.5% wide to about 8% wide, so it shrunk down a good bit. My proportion did, by chance kind of move up a bit to 0.4533, so my interval is a little bit narrower, and my p hat was just barely up a bit. And my interval is now from about 37% to 53%. So based upon this, based upon this new larger sample, better estimate, I even increased my level of confidence, I should go ahead and produce this pin because the entire interval is bigger than that 33% mark. So I'm 95% confident that the actual true proportion of my customers who would buy this pin is more than 33%, a good bit more actually, somewhere between 37 and 53%. So I definitely should produce this pin. So that's how you would do it by hand and finding and doing all those bits. You did have to use technology or a table to get your Z star, or know them if they're a popular common Z star. But I'm going to go through how to be able to do this in technology. So the first one I'm going to go to is a nice applet on the Rossman Chance suite of applets. So let me pull that up. All right, so here we have this blank applet. I'll put the link to this down in the description below. They call this the theory-based inference applet because this book does a lot of simulation-based inference, and so this is their theory-based version. Check the scenario here. You have a few options. We're just dealing with one proportion. We don't have multiple proportions, just one. I could, I guess if I was to maybe ask a proportion of my customers, I'm thinking of producing one of these two pins. No, let me try again. I would ask a group of customers, I'm going to make this pin, and then ask a different sample, I'm going to make this other pin, and I could compare those two proportions. That would be a two independent random samples. But we just have one proportion, so we're just going to do that. And obviously we're not doing means, so just pick the one proportion. If you have raw data, like a list of yeses and nos or something like that, you could pick the paste data, but we're not going to mess with that because we're given our number of successes and our sample size and all that. This applet is kind of neat because it has, can I zoom in? Yeah. Because it gives me these three boxes, and these three boxes act like a little bit of a fact family. Remember from like elementary, middle school, you learned that 3 times 4 is 12, 12 divided by 4 is 3, and 12 divided by 3 is 4. Those three kind of form a little fact family. That's what's happening here. So we were told first up that our sample size was 50. So I'm going to put in 50 for my sample size. And then we said that 21 of them said we're going to say yes to that. So when I type in the 21, I'm just going to click out of the box, and it's going to automatically calculate the 0.42. Now suppose that didn't happen. I can't delete them both. Let me reset this applet. I'll put in the 50, and then this time if I put in for my p hat, say I was not given x, and I put in just 0.42, and I click out of it, it automatically calculates my x for me. So you do have to give it the in, but then the other two are then automatically calculated. So that's kind of cool that they're related like that. So now that we have them typed in, I just need to press calculate. It gives me a nice little bar graph to be able to look at this. So I see, oh, it was a little bit less than 50%, but that's a good chunk. And then we're doing a confidence interval. So if you just check the box for confidence interval, it's already calculated there because I said calculate earlier. These calculate buttons I think are actually linked. But I do need to change this because this one we said to be 90% confident. So I'm going to press calculate, and notice that's the same one that we got from 30.5% to 53.5%-ish. And that's at 90%. Notice if I wanted to be 95, it's just as easy as just changing that. It adjusts the Z star and recalculates everything. If I wanted to quickly then be able to redo this for the 150 and the 68, so if I put in the 150 and then my 68, it then will calculate the correct 0.4533. Notice these were updating, but this confidence level hasn't updated over here. That's because we need to press one of the calculate buttons. I'll press this one, doesn't really matter. And notice it updates the bar graph and this calculation. But it does need to be 95. And so there we go. There's our 3737 and the 3530 that we saw earlier. So that is how to be able to use this applet. Nice, quick, easy. Don't need to do a lot of the calculations. Now, notice this applet is not giving me, maybe if your instructor, professor, teacher is asking for a Z star, that's missing. That's something that you would need to know. You could, if you needed to find the margin of error, they give you the endpoints, and you know the middle number right here because you put it in, this 0.4533. I could just subtract the big number minus 0.4533 or the 0.4533 minus this 3737. So either way, you could then find the margin of error that way if you kind of wanted to work backwards. All right, so now I'm going to pop up my 84. I'm going to show you how to do this in the 84. Let's turn it on. Maybe push the button again so it turns on. There we go. Okay, so now the 1 proportion Z interval is the proper name for this type of test, this type of confidence interval. So I'm going to press the stat button, and you notice you have stat, calculate, and tests. You can arrow to the right twice or just once to the left to get to tests. And notice we have test, 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 and then it starts with intervals. Do not pick this number 7Z interval. If you do, I'll show you what it looks like. Don't pick it. It's asking for, notice there's a sigma asking for here. We haven't talked about just a regular old sigma. If you had the stats, it's then saying, oh, what sigma, what's x bar, what's in. Notice we don't have x bars, we don't have sigma. That is not this, that's calculating a mean. So I do not want to do that Z interval. And we go back to, wrong one, go back to stat, tests. So let's scroll down past that. And until we get to, here we go, letter A, the 1 prop Z int. So you could just press this A button, the math button, which would then be alpha A to be able to just jump directly to it as a shortcut, or 1 prop Z int, and so let's select that. And then it just asks a few questions, just like this theory-based inference asks. It says, what's x? So notice it is asking specifically for x. So if the problem gave you p hat, you would have to do the conversion. You would have to multiply n times p hat in order to get the x, and then you should round to the nearest integer. So in this one, let's do the 50. Oh no, 50. Go back to my data. The 21. So my x is 21. Press enter. My n was 50. It will calculate p hat for me. That way, it keeps it as accurate as possible. And then it was a level of confidence, which is 0.9. Do note that it is between here. This is a 0.9 below in the Rossman chance applet. Since it said percent here, then we knew that we would type in 90 or 95. So this is 0.9. So press calculate. If you're on an 83, these are your 3 entries that you need to have, and you'll need to separate them by commas. So I'll show you what that looks like in 1 second. So then here's our confidence interval. This that 30.5% to 53.5%. It even gives you your p hat and your n, so that way you can then kind of work backwards and get your margin of error if you needed it. If I was to, I believe if I press second enter, let me try again, second enter. Nope, it doesn't do it on the 84. But let me go back to that screen. I'll show you a quick way to get that. So we're going to go to stat, go to tests, and I'm going to press the up arrow, and that's a few shorter taps on the up arrow to get to 1 prop Z int. So again, like I said, if you're on the 83, these 3 numbers are what you're going to put in. Is you'll ask 1 prop Z int, and then you'll say 21, 50, 0.9. So this time let's update it with our new x, which was I think 68. So 68. press enter or the down arrow. My in this time is 150, and then my level of confidence is 0.95. So press calculate, and it gives me what we got a second ago. There's my p hat with lots of threes, and about that 37.4% and 53.3. It's 53.30 a bit, so it doesn't give you that last zero. So that's how you do it on the 84. That's pretty easy. Now let's jump over and let's do how to do this in Excel. All right. So this first one, I have lots of a few things going on here. You don't need all this. I'm going to show you how to kind of stair step it out, but you can just get, here's the margin of error in one single formula. Here's the lower bound, upper bound in one single formula. So you can, if you're comfortable with just putting in one long formula, here's how that goes. Or you can kind of do it in pieces. I will also show you, I have a fancy version, which even checks your conditions for you and can calculate your p hat if you need it. So I'll go over that in a second, but let's just first understand the elements here. So I have my same three inputs here. In this time I'm putting in p hat and then our level of confidence. Instead of putting in the x, I'm just going to do the p hat so that way I have it. If you have a p hat that is a decimal, like our 68 over 150, you could just say equal to 68 over 150, and then we'll convert it to that decimal for you, and then you don't have any rounding issues. But let me put it back to be 0.42. You could just as easily, if you want to have an x there and then have it calculate the proportion like I have it do it over here. That's another option, but I went ahead and had it with that p hat. All right, so if you want to step it out, so notice we need our p hat, we need our z star, and we need our standard error. Those are the three base elements we need. So I already have my p hat here. Again, like I said, if you need to calculate it, then just do the division right in that box. And then let's talk about finding the z star. So this is like from the previous video. I would do norm.s.inverse. So with this first one, this is 90% confident. So I need to get it to land at 95. So let me do my middle percent dance. Everything's 100. Here in the middle is 90. Let's subtract that out. I have 10% left over, 5 in each. And in my number line here, which was the positive side, so this way is for real, I need to land right here at 95%. So that way I need this, what is the z score? So that way less than this is 95%. So I need my 90% plus my 5%. So how can I get 90% plus my 5% with the 0.9? Well, first, grab that 0.9, which is the cell B6, plus, and then I need to get to that other bit. So I'm going to do 1 minus this 90%, which gives me my 10% on the outside, and then half it. So that's the same middle percent dance that we do. I just need to add up that lower 5% with that 90%, and that gives me this z star right here. If all else fails, copy the formula. All right, then for my standard error, that's the square root of p hat q hat over n. So my p hat is a 0.42 in cell B5, so the formula for square root is SQR2, so square root SQRT. So square root of p hat times 1 minus that same p hat, and then divide by my n, which is in cell B4. You don't have to worry about parentheses to force p and p hat times q hat into the numerator because it's all multiplication, so it's all implied and understood that it's in the right spots. All right, so then if I want my margin of error, I will multiply these two numbers together, and that's what gives me my margin of error. So that's what I'm doing here, multiplying those together. So then to find my lower bound, so I have my p hat right here, I have my margin of error right here, and I'll just subtract. So p hat minus the margin of error gives me my lower bound, and p hat plus the margin of error gives me my upper bound. I like to, when I make these calculators for myself, I like to color code, usually like a yellow or something bright like that for my inputs, and then some other color for what the outputs are, so I can easily be able to see. And again, I have these formulas just printed over here for you for ease of use. On your calculator, I would not include them because they're not needed. They're usually just here for your reference. Like I said, if you want to do it in one step without all of these steps, I could get rid of all of these, and notice these formulas down here are not using any of these formulas right here, nothing in the E column, only everything over here in these three cells. So this one's the margin of error. Really, it's the formula for the z star times the formula for the standard error put together at once. And then for the lower bound, upper bound, it's the same thing. It's this p hat minus this entire, what this actual formula is, or p hat plus what this actual formula is. So once you get that done, if you feel like you're not wanting or needing all those individual parts, then you can just jump straight there. All right. Last thing, let me show you this fancy calculator. Oh, I'll show you on the fancy calculator, but I did restrict this on this calculator that, let's say if I tried to accidentally type in a -1, it's going to yell at me. Or if I type in 42.5, it's going to also yell at me. I'll show you how I do that, but I'm going to do that on the other side. So I've restricted the sample sizes to have to be integers, and I've restricted both the proportion and my level of confidence to be decimals between 0 and 1 inclusive. I'll show you, like I said, I'll show you that over here. All right, so let me show you how this works, and then I will build it with you. So again, these are my inputs right here. I just have 5 possible inputs. This input over here is just a calculator to calculate p hat if you want it. If you're given p hat already, then you can just ignore it and type it in like I have here, and I did type it in as that division, 68/50. And then but if for some reason if you weren't given it, you could do your calculations over here. So these are just inputs, and this gives me my division of the x over the n. And then these are my main inputs, just like what we had on the other slide, on the other one, and then the rest of these use it. So one added addition here is I'm checking n, p, and n, q. So I'm literally just multiplying this n times this p, and then this n times 1 minus that p to make sure that they're at least 5. And what's neat, let me shorten this down to 15. Notice that they both go red, maybe 20, yep, there we go. 20 is big enough that NQ is bigger than 10, but NP is not. So I set that up to even give me kind of it formats it with red or green to kind of tell me if it's working right or not. If you have colorblind issues, then you can use different colors that work better for you. All right. And then the other thing that I did was I did just try to show the work, air quote work, for the confidence interval, so that way I can see the p hat plus or minus my z star times the standard error, which is these same numbers here, but just written in a more useful format. And then this version of the confidence interval, p hat plus or minus your margin of error, and then here's them put together. So let me hop over to a blank version of this. This has none of the conditional restrictions that these cells have, and it doesn't have the formatting, and none of the formulas are actually active. So let's build this together. So the only thing that I have here is I have some notes to myself to make sure to tell you a few things, and then just the general structure with the colors there. So you can kind of build that out for you, pause the screen and kind of get that part built up, and you can ignore these other parts of showing you the formulas printed out. And then let's get going. So my sample size and my number of successes need to be integers. So notice right now I can type in -1, I can type in 25.3, and that's not okay. They need to be only integers. So what I'm going to do is I'm going to go to data. Oh, you can't see it. I need to click a button so you can see the full screen. Actually, just here we go. So I'm going to come up to data, and then on data I'm going to then pick data validation. So data and then data validation is what I'm using to be able to see that. So then pick data validation, and I need to adjust my settings. So I need this to be, I want it to be a whole number, and then I get to pick how I want the whole numbers to be. I'm going to leave ignore blank check so it doesn't yell at me if it's blank, and I want it to be greater than or equal to just 1. So I'm okay if 1 goes, but 1 would be way too small, but sure, greater than or equal to 1. And then I'm going to go over to error alert, and it'll be a stop style, and I'll say input error, and say must be, or in must be an integer, must be a positive integer. TID, there you go. In must be a positive integer, and I'll say OK. So now if I plug in -1, it's angry. Now if I plug in 12.3, it's angry. But if I plug in just 12, it's okay. Since my number of successes is this basically the same thing, I'm just going to fill down, and then it should do the same thing. Plug in -1, it yells at me, but I'm just going to fix this so it doesn't say in, and I'll make it say X. And so what's our values? Let's do 150 and 68. So I will go back to data validation and change my input error to say X. X must be a positive integer. All right, and then so let's find our sample proportion, which is just going to be equal to my X's divided by, and use the slash that's on the number pad or the question mark, 150. So I have my input restrictions taken care of. I can delete that message. All right, so I'm not going to link to this p hat, because maybe if you're given the p hat directly, you could type in and that would mess that up. So I'm using this just as its own little calculator to calculate p hat if I needed to. And again, I'm not going to link to over here, so that way you don't have to fill in this space. So again, I'm going to put in the same restriction for my in. So I'm going to go to data validation and say that has to be a whole number that is greater than or equal to 1. And let's say input error, and in must be a positive integer. This is not required. It's just nice so that way if you accidentally fat finger something, it kind of tells you right there that that was an oopsie. So 150, but let me test it real fast. -1, it's angry. Yep. All right, so now I need my sample proportion. So I'm going to go back to data validation and say that this time it can be a decimal between between minimum 0 and maximum 1. So I'll say okay. Oh, not okay. I'll go over to my error alert and say again input error, and say that p hat must be a decimal, or just say a decimal between 0 and 1. It does include 0 and 1. Notice I can type in 0, or I could type in 1, but that shouldn't really happen. But notice if I plug in 1.12 or 1.2, it's angry, but 0.12, it's fine. But I'm going to go ahead and say equal to our 68 over 150, just typing in the number so that we get that appropriate decimal approximation. And then the last thing is my level of confidence has the same restriction, so I'm actually just going to scroll this down. Sorry, scroll down. Let me rephrase that. I'm going to fill down, so you can drag that or do the fill down option. Put in my 0.95, and notice it has the same restriction. If I put in a 5, it's going to yell at me. It says p hat must be between 0 and 1. So I have the correct restriction. Let's just change that to say, so let's go back to data validation and say that level of confidence must be between 0 and 1. Alright, so there's my restrictions there. Oh, this note, so I can delete it. If for some reason you have a list, especially if you're working with a client, and your boss says, hey, I have this data, we got this survey, here this is. And you have a spreadsheet full of everybody's responses, and you need to count up the number of people who said yes and the number of people who said no, then use the count if function. So make a separate table in here that has a count if function, so have it look at the data and count those that are say yes, and then count those that say no. So use the count if function if you have raw data. All right, so now let's do np and nq. These are really np hat, nq hat, but I don't want to mess with the hats. So I'll say equal to in times, so shift 8 p, and notice that should be the 68, which is the same number over here, and equal to in, which is e4, times, I'm going to add parentheses and do 1 minus my p hat, close parentheses. That way I don't have to calculate q somewhere else and print it. I can just do 1 minus. And notice those two should add to 150, and they do. So let's do the conditional formatting for this. I probably should have done the conditional formatting first, because I'm going to fill down. Oh no, I can actually just highlight both. We'll just highlight both. So highlight both, and we're going to go to, let me switch my view, highlight both, and let's go to I think just under home. Yeah, under home there's conditional formatting. So under home, conditional formatting. And then I'm going to go to just the first one, just let it kind of guide it for me. And we'll do highlight rules, and we'll do a greater than. And so we'll do highlight rules greater than. And I'm going to say, well, if it's greater than 10, now it really should be greater than or equal to 10. But we'll say greater than 10 because that's the only option I had. And I want to fill it with a green text. If for some reason you you want to see if you're colorblind and you need to see the difference between red and green, maybe do the fill with the green, fill with the red, and then the one that just maybe does a border with the green or something like that. You have some other options here. So I'm going to do the green fill with the dark green text and say OK. And then I'm going to go back to this. I'm going to go back to that same conditional formatting. So highlight, keep those both highlighted. And now let's do a less than. So if it's less than, and we'll say less than 10, then I want to fill it in with the red one. So the light red fill with the dark red text. So just to test this out, I'm going to put this down to 20, my sample size down to 20. And that's working like it should. But I'm just going to overwrite this formula and type in 10. And notice it now says, it now turns white. And that should be green. So I'm going to highlight them both and go to conditional formatting and say manage rules. And then the one that is greater than 10, the cell value is greater than 10 that turns it green. I'm going to just double click on it or say edit rule. And now I have it drop down to be able to switch to say greater than or equal to. They didn't have that earlier and like the little like the suggestions ones. And then otherwise you would have to like mess with the format by yourself. So that's why I liked getting the red and the green that way. Alright, so now that if I were to just type in 10, then it is correct. But I have my formula still set up. So that's nice. Let me put this back to 150. And they're both green, so that means that NP and NQ are both greater than or equal to 10. So just like we had before, let's do our p hat. So I'm just grabbing our information so that way when I'm doing my calculations, I'm doing them from these four things. So it's a little bit redundant, but I'm saying there's my p hat, and then my z star is going to be. Well, let me grab look at my notes over here. All right, so yeah, this is the norm. So I'm going to say equal to. Since this is I'm wanting to return a z score, I'm going to do norm.s. norm.s.inverse, and I press tab to kind of take it in. So now we need the probability. So again, let's do our middle percent dance. If everything here is 100 and the middle is 95, subtract that. I have 5% total, half that, 2.5 in each. So I need to find this number so that there's 95% in the middle and this 2.5 down here, which is 97.5%, 97.5%. So I'm going to take my 95%, which is the number in the middle. So this 0.95 right here, the E6, and then I'm going to add to it this little 2.5 spot, which is everything is 1 minus the 95 is the 5 halved. So it's that middle percent dance done. So parentheses, 1 minus this 95%, that gives me 5%. Close the parentheses so that way I half that entire part. And so that second thing after the plus sign right here is 2.5% in this context. Close the parenthesis or it's going to yell at you. And there we get our 1.96 that we're looking for. Just test this, put in 0.9, 1.645, there we go. It's giving me more accurate decimal places, which is great. But I'm just needing those first few usually. Alright, so then for our standard error, that's the square root of p hat q hat over n, just like we saw earlier, but let's build this out. So sqrt for square root, tab. And here's our p hat. I think I did, which one did I do before? Yeah, I used this E5. I could have used either the p hats. I have it a little bit redundant, but so this E5 times 1 minus this E5, so that's p hat times q hat divided by n. Close your parentheses or it's going to yell at you. And there we go. So there's our standard error of about 4%. Now we need the margin of error, which is just these two multiplied together. So equals my z star times shift 8 my p hat, my standard error of my p hat. We get about about 8% or so. So these are the main components that we need. So what I'm going to do is I'm going to build out as if I'm kind of working this by hand. So this is going to be my p hat. So So I'm going to say that grab my p hat right here. I could have grabbed either, but I'm grabbing these 4 right now, using those 4. And then this is my critical value, so equal to my critical value, so plus or minus my critical value times my standard error. By the way, these symbols are greater than or equal to, plus or minus, and this time symbol, let me show you how to get those. So if you press on I'm on a Windows computer, so if I press the Windows button and period, then you get, you should be able to get listings of emojis or different symbols. So hop over to the symbols, and then you can go through the options. There's different kind of menus at the bottom to be able to find the ones that you want. And so that's where I find the multiplication x, the plus or minus, and the greater than or equal to that I used. All right, and then so then here's my same p hat. I might as well just grab the number right above, and then here I'm going to multiply this cell times this cell. Again, I could have grabbed the ones over on the side, but they're the same thing. It just kind of feels like I'm working it by hand. That's why it's air quote work. And then lastly, for my lower bound, I'm going to take my p hat and then do the minus part for my margin of error, and then equal to my p hat plus, oops, that's the equal sign, plus my margin of error. And again, I could have chosen the ones over here, but it's kind of felt nice to come from that math there. So now I have this working calculator. I can put in whatever x I want, whatever in or p hat I want. If I have the x, I can convert to the p hat over here, and it'll just work. So hopefully that helped. I showed you how to do the confidence intervals by hand. We saw how to do it in an applet online on the Rossman Chance applets, how to do it on the 84, and how to build fancy things, and maybe taught you a few things about Excel and how to make nice calculators like this. All right, hope this helped, and I'll see you in the next one.